Okay, so the first thing we're going to do is we're going to say, okay, I have two unknowns here, so I'm going to solve for one of the unknowns. So I'm just going to solve for y so that I can substitute into this y to the first rather than substituting in for the x to the negative 1. So that gives us y is equal to 10 minus x. So plugging in for y, 10 minus x to the negative 1. And that is now our objective function in one variable. So at this point, we're really just in the first derivative test idea. So we are going to take our first derivative. The 10, of course, is going to go to 0. Then we have negative 1, bring down the negative. So we have a negative times a negative, giving us a positive x to the negative 2. Now, just like we did with the first derivative test, our negative exponent we're going to rewrite as a positive in the denominator. And then we're going to get a common denominator by multiplying by x squared over x squared for the first term. So that gives us negative x squared plus 1 over x squared. And that is our first derivative. Now again, from here on, all we're doing is applying that first derivative test. So with our first derivative test, we set the numerator equal to 0, and then we set the denominator equal to 0. Solving the numerator is equal to 0, we get x squared is equal to 1. So taking the square root, we get x is equal to plus or minus 1. Over here, we get x is equal to 0. Now, with the first derivative test, we draw our number line. Now, do keep in mind that the assumption in this problem is that x is greater than or equal to 0. So the fact that we get a negative 1 is completely irrelevant for us because x has to be greater than or equal to 0. So our number line is going to start at 0. And that means that our only critical number of interest here is going to be 1. So I plug into the left and to the right into our derivative. So let's say I plug in, 0.5. So I will have negative 1/2 quantity squared plus 1 over, and honestly what you should see is that this denominator is x squared, so that is always positive. So no one really cares a hoot what the 0.5 squared is. That's going to give you a positive. So you have negative, you'll distribute the 2 here, you'll get negative 1/4 plus 1. So that gives us a positive over a positive, giving us a positive overall. To the right of 1, if you plug in, let's say 5, you can work through this and you will see that you get a negative. So that tells us that we are going up and then we're going down. So at x is equal to 1, we have a maximum. All right, so what we need to do here is we need to say that there is a max at x is equal to 1. To find out our corresponding y value, we go back to our constraint, which was x plus y is equal to 10. If I plug in x is equal to 1 here, that tells us that y is equal to 9. So it's a max at x is equal to 1, y is equal to 9. Now, if you look at the structure of this objective function, we have y minus 1 over x. And the question is, what is going to minimize this function? Now, if you just look at this, this is going to have a vertical asymptote at x is equal to 0. Okay? And that is very relevant because remember that vertical asymptotes, we never actually hit that value. So if we had x is equal to 0 so if we had x is equal to 0, this would mean that all of the material or all of the value would be in y, and then that would potentially minimize it. But we have a vertical asymptote at this x is equal to 0, so we're never actually going to hit x is equal to 0. So if you look at this constraint, x plus y is equal to 10, there's not going to be an x is equal to 0 here because you have a vertical asymptote. So you would have to say that there is no minimum for this question, okay? Now, this part about finding the minimum, you kind of have to play around with it and know more about the property of this particular objective function. So again, I just want to reiterate, usually on the test, what I would ask is just the very obvious first derivative test that comes, or the answer that comes straight from the first derivative test. So if you can get down to here, maximizing at x is equal to 1, y is equal to 9, that is good enough for now, but eventually you want to work up to understanding why there would be no minimum. And that's because it would happen if one of these guys, like if this y, or if we were subtracting off a big number here, and that big number is never going to actually hit because of the vertical asymptote.